This will happen if
F is an algorithm in which the process having the
shortest job first schedule, non-preemptive. Start now. The first presenter is Nur Ariesya binti Othman. The second presenter is Nur Alisha Najihah binti Mustafar. The third presenter is Nur Izzati Farhana binti Amri. And the last presenter is Nur Diana binti Che Zaid.
Shortest job first or SJF is an algorithm in which the process having the smallest execution time is chosen for the next execution. There are a few characteristics for SJF, which is to ensure the shorter jobs are executed first. SJF improve the throughput of the process, hence they possibly have less turnaround time. For batch type processing, SJF algorithm is helped where the waiting time for job completion is not critical. SJF enhance the output of the job by offering shorter job execute first, which mostly have a shorter turnaround time. It is also associated with each job as a unit of time to complete. SJF has two types, which is preemptive SJF and non-preemptive SJF. Since we chose non-preemptive SJF, so non-preemptive SJF is the process will hold the CPU until the process enter the waiting time state, only if a CPU is located to the process.
The disadvantages of SJF is it causes suffer with the problem of starvation. If the arrival time for processes differ, means that not all processes are available in the ready queue at time 0 and some jobs arrive later. Processes with short burst time may have to wait for the current process execution to finish, because in non-preemptive SJF, when a process with a short duration arrives, the execution process is interrupted. This leads to the starvation problem. This will happen if shorter tasks keep pouring in, but the problem can be overcome by using the concept of aging.
Advantages of shortest job first scheduling. Based on its definition, shortest job first scheduling (SJF) is a scheduling algorithm that chooses the process with the shortest execution time to run next. Means that the shortest processes are executed first, then followed by the longer processes. The next advantage is the waiting time of SJF is minutes, because SJF gives the lowest average waiting time for a specific set of processes. SJF are suitable for group jobs where runtime are known in advance. SJF is optimal if no preemptive is allowed. Other than that, SJF is easily implemented in a batch system because we know that the CPU time is required. A burst time estimated can be obtained from the work description for the batch system of a long-term scheduling.
For the conclusion, after completing this project, we can conclude that SJF is a method of selecting the process with the shortest execution time for the next execution. This algorithm approach is useful for the batch type processing where waiting for jobs to finish is a concern. Despite the fact that a process with a small burst time starts, the present process is withdrawn or preempted from execution, and the task with the shortest burst time is run first. Besides, we also realize that SJF cannot be used to schedule CPUs. It's because there's no way to know how long a CPU burst will last in advance. Thank you.
So I'll be starting with my part to input two process in our Java coding. So let's rerun. So enter number of process. I'll enter 2. Process 1 enter arrival time, which is 0, and burst time, which is 6. So for process 2 is 1 for arrival time and 4 for burst time. So we can see the output here. For arrival time and burst time, the output comes with in table like this. Then completion time, we can see it in Gantt chart later. So turnaround time, how they got the turnaround time is from the formula, which is completion time minus with arrival time. So 6 minus 0, turnaround time 6. 10 minus 1, turnaround time for process 2 is 9. For waiting time, the formula is turnaround time minus with burst time. So 6 minus 6 is 0 for process 1 waiting time. 9 minus 4 is 5 for process 2. For the average turnaround time, sums of turnaround time divide by 2 for the process, so we got 7.5. While for the average waiting time, we sum up the 0 plus 5 divide by 2, which is 2.5. So next, I'll be showing about the Gantt chart. So SJF is about execute process from smallest to biggest. So as we can see, for process 1, arrival time is 0, and for process 2, arrival time is 1. So the first one, how SJF is work, when the arrival time is 0, it will execute the process first. So like this Gantt chart, the process 1 is execute first for burst time 6. Then for process 2, the arrival time is 1 and the burst time is 4. So it execute letters with the smallest to biggest. If I have another process here, process 3 with burst time is 7, so it will execute the process 2 first, then it will execute the next process, because it execute process from smallest to biggest. So that's all. Thank you.
In this example, I will put 3 input into the system. So you need to enter 3 in the number of process. For the first process, you can put the arrival time. Let's say the arrival time is 0 and the burst time is 4. Then you can continue to put the input for the second process. Let's say the arrival time for the second process is 1 and the burst time is 2. Then for the third process, you can just repeat the same. Let's say the arrival time is 2 and the burst time is 3. So there will be an output over here. You can see there are a result for completion time, turnaround time, and waiting time. The formula for the turnaround time is completion time minus arrival time, while the formula for waiting time is turnaround time minus burst time. The result for turnaround time for process 1 is 4, process 2 is 5, and process 3 is 7, while the result for waiting time for process 1 is 0, process 2 is 3, and process 3 is 4. And there are also a result for average turnaround time and average waiting time. The average for turnaround time is 5.33333335, and average for waiting time is 2.333333. For Gantt chart, P1 will arrive first because the arrival time is 0, and P1 will end at 4 milliseconds. Next is P2 because the burst time is 2. Because in non-preemptive, we need to select the shortest burst time. The last process is P3, and the process will end at 9 milliseconds.
Bismillahirrahmanirrahim. Assalamualaikum. My name is Nur Farhana, binti Amri. My matrix number is S58269. I'm the 4th presenter for this video demo. So this is our coding for shortest job first SJF non-preemptive. This is the variable, and this is where the looping for arrival time and burst time. And lastly, this is where the output will be printed out. So I will run this coding. In this process, there are 4 processes. The first arrival time will be 0. The burst time will be 7. The arrival time for process 2 will be 2. And the burst time will be 4. The arrival time for process 3 will be 4. And the burst time will be 1. And lastly, the arrival time for process 4 is 5. And the burst time is 4. So this is our output for this whole process. How do we find turnaround time? Turnaround time, we can find it by minusing between completion time and arrival time. For example, for process 1, 7 minus 0, turnaround time will be 7. For process 2, 12 minus 2, turnaround time will be 10. For process 3, 8 minus 4, the turnaround time will be 4. And lastly, for process 4, 16 minus 5, the turnaround time will be 11. So next, how do we find waiting time? Waiting time we can find by minusing turnaround time and burst time. For example, for process 1, 7 minus 7 will be 0. 10 minus 4, for process 2, the waiting time will be 6. And for process 3, 4 minus 1, waiting time will be 3. And lastly, 11 minus 4, the waiting time will be 7. Next, how do we find average turnaround time? Average turnaround time we can find by addition all the turnaround time and divide it by the number of process. In this case, we can add 7 plus 10 plus 4 plus 11 and divide by 4 because there are 4 processes. And the total for turnaround time is 32 divided by 4, we'll get 8. And for average waiting time, it's the same as turnaround time where we add all the waiting time and divide it by the number of process. So for this process, 0 plus 6 plus 3 plus 7 will equal to 16. And 16 will be divided by 4 and the average waiting time is 4. As for Gantt chart, process 1 will arrive first because the time arrival is 0. Process 1 will end at 7 milliseconds. Next is process 3 because the burst time is 1. We cannot select process 2 because in shortest job first, we need to select the shortest burst time. So in this case, process 3 will arrive first, then process 2. Process 3 will end at 8 milliseconds. Then in the ready queue, there are process 2 and process 4. As process 2 and process 4 has the same burst time, we need to apply FCFS, first come first serve. Then the next process will execute is process 2. Process 2 will come before process 4. So process 2 will end at 12 milliseconds. Lastly, process 4. Process 4 will end at 16 milliseconds. Total of this whole Gantt chart should be equal to the burst time. So this is 16 and this also must be 16. Thank you.
My name is Nur Diana binti Che Zaid. My metric number is S58699. So here is our coding. Here where the user will be asking to input the data for the process. Here is the variable declaration. Loop to entering arrival time and burst time. While loop to entering the burst time and arrival time. Here is the loop to calculate completion time, turnaround time, and waiting time. And here is where the output will be printed. And here is for the average turnaround time and waiting time. Now I will run the program. So the number of process of mine is 5. First arrival time is 0 and burst time is 9. Second is 1, burst time is 4. Arrival time for the third is 2, and burst time is 5. Next is 3 and burst time is 7. And the last one for the arrival time is 4 and burst time is 3. So here the output. For the completion time, it will adding the burst time into the completion time. First completion time is 9, second completion time 9 plus 3 is 12, and third completion time is 12 plus 4 is 16. Next is 16 plus 5 21, 21 plus 7 is 28. To get the turnaround time, completion time minus arrival time. 9 minus 0, 9. 12 minus 4 is 8. 16 minus 1 is 12. 21 minus 2 is 19. 28 minus 3 is 25. And for the waiting time, turnaround time minus burst time. So 9 minus 9 is 0. 15 minus 4 is 11. 90 minus 5 is 15. 25 minus 7 is 18. And 8 minus 3 is 5. To get the average of turnaround time, adding all the turnaround time and divide by 5, and the answer is 50.2. For the waiting time, adding all the waiting time and divide by 5, the average is 9.6. Here is the Gantt chart of mine, and the first will be execute is P1 with the burst time is 9. Next is P5 with the burst time is 3. Next is burst time 4, which is P2. And next is burst time 5, which is P3. And the last one is burst time of 7, which is P4.